Hi everyone and welcome. In this review note, we are going to configure a site-to-site VPN between two Palo Alto firewalls. Before getting started, make sure that you have your topology patched. Ensure that you can ping from the client VMs in each one of the sites to the interface of the firewall in the internet zone at the other site. And also ensure that if you send traffic from the client VMs in both sites to the web server on the internet, that the web server sees the source IPs as the IPs on the internet zones from the appropriate firewalls. Once you've got all that set up, we can get started on configuring the VPN. First thing I'm going to do is create a layer 3 security zone. Go into network and zones. And this one is going to be for the tunnel. So we'll add this in. VPN tunnel 01 is going to be the name. The type will be layer 3 and OK. And we're all good. Next thing we're going to do is create a tunnel interface. Network, interfaces, select tunnel, and we're going to create new. The interface name we specify by applying the number that's going to be on the end of it. So the name's actually going to be tunnel dot and then whatever that number is that you provide. We will put a comment in here. In this case, this will be the tunnel to the BC LAN. The virtual router is going to be our virtual routing interface that we already have. And the security zone is going to be the tunnel zone that we just created. And that's all we need to create our interface. Next thing we're going to do is add a static route so the firewall knows how to forward the traffic to the LAN at the other site. Select virtual routers, select our routing instance. Notice we have our tunnel.10 interface included. Static routes, add, this will be VPN to BC. Put in the LAN network address for the BC site. The egress interface is going to be our tunnel interface. And in this particular case, we do not need a next hop. So we will specify none. And OK. That's all we need to do to configure our static route. And we are now configured for that. Next thing I want to do is take a look at a couple of different types of network profiles that are going to be part of the tunnel. One is IKE crypto and the other is IPsec crypto. We can see that some of these are already created. Let's go and look at the default. And we can see that the different parameters that we would configure are the Diffie-Hellman group, the authentication protocol, and then two different encryption protocols that we can select from, along with the lifetime for the key. Since we're going to be connecting to different Palo Alto firewalls, we're just going to use the default. Remember that we need to make sure that the firewalls at each end, or the appliances at each end that are going to create the VPN tunnel, have to agree on the protocols in each of these areas. So we would need to make sure that these are configured the same on both ends. Same thing looking at the IPsec parameters. Again, we have a default. This is the one that we're going to use. This is very similar to the other in that we have Diffie-Hellman group, we have encryption, we have authentication, we have the lifetime for the tunnel before it gets renewed. The other thing that we have here is that we specify the protocol as being either ESP or AH. Again, we're not going to make any changes to this. One thing we do have to create is an IKE gateway, and that is what allows us to specify how the firewall is going to connect to another device in order to create the tunnel. In IKE gateways, we'll notice that we don't have any, so we'll add one. In this case, we're going to create Toronto to BC. We are going to specify that we are going to prefer IKE version 2. It's going to be IPv4. The egress interface is going to be Ethernet 1.1. So this is the actual physical interface that the traffic is going to egress. Local IP address, we will select from that interface. In order to connect to the other end, we're going to specify its IP address. You can always use an FQDN if the IP address is not static. This is the IP address of, again, the interface on the other firewall that is connected to the internet zone. And we also have to specify how we're going to authenticate. In this case, we're going to use pre-shared key since we haven't covered certificates yet. And all we need to do is put that information in twice. We don't need to worry about local or peer identification under these circumstances. And OK. And we can see our IKE gateway has now been created. Now, another thing we need to do is make sure that we have security policies that will allow traffic to flow both out of our firewall and into the other one, along with traffic that will flow from the other firewall into us. To do that, we will create two security policies. The first one we'll create is internal to BC. And our source zone will be internal. And our destination zone will be our tunnel. In this case, we're not going to be putting any restrictions on the type of traffic. So we'll simply say OK. You can see that that was created here. And we will create one more to allow the return traffic. In this case, our source zone is going to be the tunnel zone, and the destination, of course, is going to be internal. That's all we have to do there. So our two zones are now created. The last thing we have to configure is going to be an IPsec tunnel. We're to network, IPsec tunnels. We don't have any, so we need to create one. This will be the Toronto to BC peer. The tunnel interface is going to be the one and only one that we have, which is tunnel.10. This will be auto-keyed. It will be an IPv4 type of tunnel. The gateway is going to be the IKE gateway that we created a little bit earlier. And if you remember, we were talking before about the IPsec crypto profile. We are going to use the default that we mentioned before. So we'll just leave this as default. And say OK. And our tunnel is now configured. We need to commit this so that our changes are saved, and then we'll be good to try this out. While the commit's taking place, I'm going to go and configure the firewall on the other end. And when we're done with that, we'll get back together and we'll see what has happened as far as connection is concerned and try everything out. Okay, we are back, and the firewalls have been configured on each end. One thing before we go forward is that I noticed I had made a mistake on configuring the IKE gateway. So I'll go back and take a look at that for a second. The thing that I made the mistake on here was that when I was configuring the peer address, I accidentally entered the local address. So basically it was going to try to create a connection to itself. So I had to go back and edit the peer address on the gateway to 172.17.1.2 rather than 172.16.1.2. Now, up on our IPsec tunnels, we can see that the status for the tunnel interface itself is green. So that's kind of like saying that we've plugged the two devices together, and the connection is now made and it's been enabled, but no traffic yet. The IKE gateway and the tunnel itself will not be enabled until we start sending traffic through it. So let's do that. I'm going to go over to my VM, which is on the Toronto site, and I'm going to ping the client VM on the BC site. And we can see that that starts flowing through. I'll just stop that traffic. And if we go back now and look at our firewall, and I will do a quick refresh. And we can see now that both of the IKE gateway and the tunnel are now green, so they're activated. And we can look at some information here that can be very, very useful. So for example, I can look at what routes are in the routing table. Switch this out a bit. And we can see, for example, our default gateway, which goes out to out through the internet interface. We can see the local interfaces that we have configured on the device. We can see the IP addresses explicitly assigned to those interfaces. And then we can also see the static route we created that goes through the tunnel interface out to the BC site. Other things that we can look at that can be interesting, if we look at the IKE gateway, we can see as an example what version of IKE we're using, what algorithms are in place, so pre-shared key, Diffie-Hellman2, AES 128, and then SHA-1 for authentication, and then the dates. And also we can look at the actual tunnel info. So here, again, we can see the local IP, we can see the peer IP. If we had any restrictions on IP in that, we would see that here. We can see how many packets have gone and returned and how many bytes have gone and returned through this tunnel. And you can also see all this information using commands in the CLI. It's just a little bit easier to do that here since we are already in this position. The last thing we're going to want to do is make sure that NAT is still working. I'm going to run TCP dump to collect some traffic. I'm just going to collect ICMP traffic because I'm going to ping it for testing. If I spelled correctly, it'd be even better. We'll go over to, again, our VM on the Toronto site. And we'll ping out to our internet VM. And if we go out and look at this, if I look at one of the incoming packets, we can see that the source address is 172.16.1.2, which again is the IP assigned to the firewall, not to the VM itself, which means NAT is working the way we expect it to. That is a wrap for the video. Hopefully you found this helpful, and we'll see you next time.